Now let's move beyond the simple and let's move into the complex. Fractions, that is. Here I have this fraction that looks like a nightmare, but we can make good sense out of this and we can simplify this, believe it or not. We want to take this fraction, and right now it looks kind of ugly. Ugh. We'd like it to look like just one thing, so if I'm dreaming of the perfect fraction, I want it to be just one thing over one thing. And let's do that. Right now I have like a little fraction here, and I have a little fraction plus another fraction. This is gross. I gotta fix this. So here's what I would suggest if we want to simplify these complex fractions. Let's kind of isolate one part of this fraction at a time. So we're going to look at this whole big numerator first, and then we'll look at this whole big denominator. And so what I'm going to suggest that we do is let's combine these two fractions, my little fractions, in my big numerator. And in order to do that, I'm going to have to come up with a common denominator. So here I have an x minus 3 in this denominator, and I have an x plus 2 in this denominator. And if we think about what the least common denominator would be, well, let's think about like if I had, let's sidebar this and think about regular old fractions. If I wanted to add 1/3 plus 1/4, I would think about what is the least common multiple of these numbers. Well, there's no common factor between these two, so the first common multiple between the two of them is going to be whatever the product of those two will be. So I would multiply this fraction by 4 over 4, I'd multiply this fraction by 3 over 3, so I'd get 12ths as a denominator. Over here, I don't have a common factor between x minus 3 and x plus 2, so the least common denominator is going to be whatever I get when I multiply these two denominators together. So I'm going to multiply this x plus 2 fraction by an x minus 3 over an x minus 3, and I'm going to multiply this fraction by x plus 2 over x plus 2. So remember, this is legal because this is just multiplying that by 1. So I'm going to kind of table this denominator for a second, and this numerator is going to equal, I'll put a little n to remind myself, this will be 2x plus 4 when I multiply x plus 2 times 2 over, and I'm just going to leave this as x plus 2 times x minus 3 plus, and this is just a 1, so this becomes x minus 3 over x plus 2 times x minus 3. So if I combine all of this stuff, this is going to be 2x plus x, which is 3x, and then 4 minus 3 is plus 1, all over this big denominator, x plus 2 over x, and times x minus 3. So that's just my numerator. Let's work with my denominator now. And I have, well, this is just 5 over x squared minus 9. I could factor this, so this is 5 over x plus 3 times x minus 3, when I factor x squared minus 9. So I have this numerator and this denominator, so let's kind of combine these two things. And this is going to look like, let's see, I'm going to stick this right in the middle here, 3x plus 1 over x plus 2 times x minus 3, all over my big denominator, 5 over x plus 3 times x minus 3. Now is probably a good time to take a look for restrictions. So let's fill up that restriction sidebar again. So here's my restriction bank. And right now, as I'm looking at this, I see that x can't equal negative 2, can't equal positive 3, and it can't equal negative 3 either. So this is negative 3, negative 2, and positive 3. That's what I have so far. We'll see if I add any more to that. Now I can think of this as I've got one fraction divided by a fraction. I got to think about when I'm dividing fractions, just like when we divided normal fractions in the last example. Now I want to take this numerator, multiply it by the reciprocal of my denominator. So then what I'll do is I'll say this is 3x plus 1 over x plus 2 times x minus 3 times the reciprocal of this, which is x plus 3 times x minus 3 over 5. And it looks like I'm encroaching on my restriction bank, so let's kind of block that off here. All right, so I'm now multiplying these fractions, and I'm going to do just like I did before, where I can reduce any common factors. So I can reduce an x minus 3 here, an x minus 3 here, and that looks like that's going to be it. So my final solution will be the product of all of this stuff on top. So this is 3x plus 1 times x plus 3 over x plus 2 times x minus 3. Now notice I didn't add any new restrictions to this, since when I flipped my denominator, I didn't have any x's in this new denominator. So my restrictions are what they were before. So I'll just leave that as x cannot equal a set of numbers negative 3, negative 2, and positive 3. And there is my simplified fraction. It's one thing over one thing. It doesn't look quite as simple as just a number divided by a number, but this is still one product divided by one product. So I like that. Here is another complex fraction. Oh, there's the answer to a complex fraction. Take a look at your notes to find the complex fraction problem, and you can pause the video and check out the solution when you're ready. So here is my simplifying of this complex fraction. You can kind of follow my work a little bit here. And the one thing I didn't do is I didn't state restrictions. So let's do that right now. If I were to look through all the restrictions, I'm just going to kind of follow all of my denominators and see what comes out here. So I have x cannot equal, this would be, can't equal negative 2/3. That comes from this denominator here, nothing there, nothing there. Now I have 3x minus 2, so x cannot also equal positive 2/3. It looks like those are all of my restrictions for this one. So hopefully that worked out.